In this blog, I will be talking about use of Altair Monarch for data preparation of Feko simulations. Yeah, let me present the overview of this particular topic. First, I will be talking about the introduction to millimeter wave scanners and the problem definition. After that, we will be discussing about the design workflow and then Altair Feko, how we can use Altair Feko for electromagnetic simulations. Then once we have that, then I'll jump on to the Altair Monarch to talk about the data preparation using data Altair Monarch. After that, Altair Compose is there to do the signal processing algorithms. Then, of course, the final conclusions. And also in the Altair Monarch data preparation section, I will be presenting about a short demo of Monarch, pulling the out files from Feko into Monarch and get the required data for analysis purposes. Yes, actually, coming to the problem, let us understand a brief introduction, right? Kind of a problem description we can think of like a millimeter wave scanner is a whole body imaging device used for detecting objects concealed underneath a person's clothing using a form of electromagnetic radiation. In active scanners, the millimeter wave is transmitted from two antennas simultaneously as they rotate around the body. Okay, the wave energy reflected from the body or the other objects of the body is used to construct a three-dimensional image which is displayed on a remote monitor for analysis. Yes, yeah, you can see the image. Most of us were standing in the airport security for the security checkup. And yeah, this is just a problem definition or introduction we can think of. And in problem definition, you can see over here, I got like millimeter wave scanner and then Altair Feko, Altair Monarch and Altair Compose. These are the three different tools that I used in setting up the problem. Yes, Altair Feko, we can perform the simulations like using horn antenna of 1 gigahertz and of which is having a return loss of less than minus 10 dB. You can see a transmitter antenna and receiver antenna, which is transmitting the power and receiving the power. And then after that, we are going to scan the human body by rotating the antennas in 360 degrees along the 360 degrees of theta and z direction, so that we will be having a lot of data points that needs to be worked on to form the image. You can see over here, once we generate, each simulation will be generating an out file. That means for every point we'll be having a transmitted power and received power. That means like we will be generating tons of data files that require data extraction. Okay, you do have the position XYZ and power coupling transmitter or receiver. Then after that, we do have a Altair Compose. Compose is a signal processing algorithms. Then image reconstruction algorithms. Of course, once we have data is available in the streamlined fashion, we can use the signal processing algorithms to process the data. But here the important thing is handling the lot of data in Monarch, streamline extracting the information using Monarch in a proper fashion and streamline the data like position coordinates, transmitted power and received power, everything into a streamlined data and then exporting into an Excel sheet. That is the main goal of this particular block. Okay, you see, let us assume that if you take a simple dielectric cube, you don't have, it's a small cube of dimensions of zero point 0.5 by zero point 0.5 by zero point 0.5, and I do have radius 2.5 meters and angle 0.0 to 360 degrees, and height is of 0.5 meters. And if I consider a angle of 1 degree, resolution and a height of 0.1 meter as I was talking about, we will be having 1805 files, simulation files that needs to be worked on for a simple dielectric cube. Imagine a human body of zero point 0.5 by 0.1 by 1.75 dimensions. And if you would like to perform the same simulations of the same degree of resolution, see, we had like 18,050 files. Think about if you would like to have a further finer resolutions, and your number of simulation files will be pumping up hugely. If you wanted to go from 1 degree to 10 degree, then you'll be having 180,500, yeah, approximately 100, 200, close to 200,000 files. That means it's a lot of data that is available from the FICO that needs to be worked on to extract the data using Monarch. That once we set the templates in Monarch, we can work with them closely and then streamline the data for further data image processing. Okay, workflow. You see over here, just the same thing as we had the previous slide. We got the simulations, all the simulations were done, and we'll be creating it at template creation using Altair Monarch Data Prep Studio. We are going to create a template and export the Excel sheet. And once we have the Excel sheet of data with the position and transmission reflection coefficients appropriately or reflected power, phase, what are the information from our out files, we are going to streamline in Monarch, then we are going to give to Compose. Then Compose, we can use it as a signal processing algorithms. We can process the data and form a image of this particular one to detect the concealed weapons. Okay, in the first section, Altair Feko Electromagnetic Simulations. Okay, that is the first section. Like if I take the three different parts, the first part is Altair Feko Electromagnetic Simulations. Actually, Feko is a leading electromagnetic simulation software that uses multiple frequency and time domain techniques. Of course, true hybridization of these methods enable the efficient analysis of broad spectrum of electromagnetic problems that are related to antenna placement, RCS studies, electromagnetic compatibility, and interference studies, etc. We can perform a broad range of electromagnetic problems can be easily solved or simulated using Altair Feko tool. This is some introduction about our tool that we are going to use perform the electromagnetic simulations. There is a very interesting feature called component library feature is available in FICO. We are going to use that particular feature to generate the horn antennas working at 1 gigahertz. These are the dimensions of the horn antenna that we pulled out from component library feature. Yeah, the horn antenna dimensions, you can see all the things, HA, HB, H1, and stuff like that. On the width 1, with A, with B, everything is there. Then once we have the horn antenna, we need to study the characteristics of this particular horn antenna. You can see all the dimensions, approximate dimensions and schematic of this particular horn antenna and simulated radiation pattern of the horn antenna. This is the radiation pattern, or this is the radiated power which we are going to send to the human body, and we are going to sense it. We are going to send the signal and we are going to reflect the signal. Okay, yeah, that we made sure that the antenna got the right radiation pattern of 20 dBA gain performance. Okay, so we are ready, we are set, we are all set. Our transmitter and receiver antennas are ready for performing the simulations. Okay, once we have the one, this is the transmitter antenna for me and receiver antenna for me. Then you see over here Feko simulation using antennas for transmitter and receiver antennas at 1 gigahertz. We could able to use a parametric sweep plugin that is available in Feko. We can sweep these antennas along around 360 degrees and scan the human body, right? As we are talking about, we can rotate these antennas along around the Z axis, and also we can move these antennas along Z axis so that we can get the complete image of the human body. Okay, and you can see over here parameters will click in theta and Z direction so that we can compute the received power. And this is a screenshot from the FICO, how we can run the parameter sweep, create models. You can see this is the out files which are going to have the position information as well as the transmitted and received power from the horn antennas. S11 is nothing, but you can see here S11 means the scattering matrix, and S21 is nothing but the transmitted power, reflection coefficient and transmission coefficient of this particular simulation. Okay, of this particular antennas or of this particular configuration, whatever we have in this particular simulation. Once I have, okay, we had a number of simulations were performed. Data files are generated, as I told you already, human body with dimensions of zero point 0.5 by zero point 0.1 by 1.75 meter cube. If I can think of that much, this is the human body dimensions. If the radius is 2.5 meter and angle is 0 to 360 degrees and height is 5 meters. That's a cylinder, right? I am thinking of it, the cylinder. And I would like to have the antennas needs to be rotated every 1 degree. That is the resolution I was expecting to get the data points, to sample the data points. Then the height is of zero point 0.1 meter, okay? And that means you will be having 361 by 50. That is nothing but 18,000 points. That's what approximately, that's what I spoke to you. That means it's a huge number of data files, huge number of data points. That means approximately 18,000 data points were there to need to be streamlined. For every data point, I would like to get the information of the transmitted power and the received power, the reflected power, I mean to say, transmission coefficient and the reflection coefficient information for each of this particular point, for this particular 18,000 points. Okay, we do have data prep options, exactly, extracting position and data. We need to get the position information as well as the transmitter and receiver coupling values from thousands of dot files, out files. We have a lot of files, right? As I told you, we had like 18,000 files for that particular simple simulation. In case if you have a further finer resolutions, that the number will be pumping up by 10 times and it will be much more. And here you can see over here in this slide, I do have two different options. Option one is to use because there is a inbuilt programming language available in called Lua scripting in PostFico. One can use that particular Lua scripting in PostFico and write a script, and they can they can extract the data and power values. And also there is other option is also there. Compose is also, compose software is there. One can write the script in there itself, and also they can get the information. The problem is knowledge. One need to know the programming. Knowledge of programming is required to Lua and OML. And the second disadvantage is we need slow parsing, right? And we need to extract from thousands of data points. Compose or any Lua scripting might slow down in parsing these values. Therefore, we have a tool called the solution for this particular problem is Altair Monarch. We can literally on real time, we can get the information from all the files, okay, in literally no time, probably in less than few minutes or something like that. We can have all the information can be pulled out from the files. Okay, and let us jump on to understand about Altair Monarch. As I told you, Altair Monarch here we are going to use as a data preparation tool, and Altair Monarch is a desktop self-service data prep studio. You can eliminate. You can see over here. You can access any complex data, and you can use blend and join. Basically, you're going to create a template for your work, and that can eliminate the manual work and human error. And also, it can easily handle big big amount of larger amounts of data in Monarch without having any problem. Once we have that particular thing, we can easily export to any format that we are interested in. Okay, yes, Altair Monarch, you can see over here as we had a just brief introduction about Altair Monarch. Altair Monarch, we can have the notepad, note files, or text files, or Excel files, or PDF files. That is the input that we are going to send to the Monarch. Once we send the data to Monarch, we can extract the information by setting some traps in the Monarch Prep Studio, and then we can consolidate the data how we want. And then of course we have the output data in Excel format or text file or PDF format, how we want it. We can get the data from there. Exactly, we can streamline our data and get it. Okay, here the workflow you can see here. Feko to produce dot out files. We already got the out files. Then we are going to rename out file to .txt file. Of course, we can eliminate that one. Monarch can handle the out files without having any problem. And then read .txt data via Monarch for data transformation and output conversion. Actually, as I told you here, this is where we are going to, once we read this particular data, then we are going to design a template, okay, report template basically by setting up the traps. Exports, once we have that particular thing, we can export the structured resultant data for our post-process consumption. Okay, you see over here, this is our text input data, and we are trying to, you can, how it is going to look in Monarch. Of course, I'm gonna give you a short demo over here in after this particular slides of this after this particular section. You have the third text the input file which we got it from Feko. You can see over here this is the position coordinates, and once we bring in that particular thing into Monarch, this is how it looks, because we would like to set a trap over here, and we would like to read the XYZ coordinates of this particular out file. Also, we'll be setting up some more information to get that particular reflection and transmission coefficients in the Monarch design. Okay, and as I told you, the second slide, this is the continuation of the previous slide. We already got the XYZ positions and the same text file. I do have the transmission and reflection coefficients. I would like to use them appropriately. Okay, XYZ coefficients, and then I do have the reflection and the transmission coefficient values. Okay, once I have everything available, the structured report design was there. I can pull all the files into Monarch, and I can get the streamlined data. You see over here, I can get the S11, S21, S11, S21 of for different files. Okay, XYZ locations and everything. We can have it in one shot. Okay, let me give you a short demo of this particular Monarch template. How we set up the Monarch template and stuff like that. Before that, I would like to go ahead and show you how the out file looks, that we have performed the simulation in Feko, and Feko had all this information, right? Position information there, position you see over here. This is the position information I am interested in this particular file, and also I am interested in the reflection and transmission coefficients from this particular file. Okay, I am interested because, like I said, I'm interested in the XYZ positions and also S11 and S21 parameters of this particular file. This is the one file. If we perform the simulations, we'll be having 18,000 files, or maybe more if you want to have further precision. We have huge tons of data will be available. Okay, and we are going to open this particular file in Monarch, and you can see over here, this is the Monarch data prep studio, and I already set up a prep design. Okay, you can see over here, I had a report design. I pulled out all the XYZ information by setting up the trap. Actually, there is a workflow that is available to set the traps and all in Monarch. I'm not going to discuss about that, but this is how we did. We just want this information, and we set up the traps in Monarch, and we got the XYZ information appropriately for the transmitter and receiver antennas. Okay, then once I have that particular thing, I just similarly also I just made it into two separate sections so that my job will be easy. And you see here there I got my XYZ values. Here I am trying to pull my S11 and S21 information from that particular file. Okay, and once I have this particular thing, I can, as I told you, I can keep, if this is, I made also, I joined these two things so that I can form a one good big table. You see over here, I got XYZ coordinates and real part, imaginary part, magnitude, phase, and everything for S11 and S21 of this particular thing. Now I want to add like 18,000 files to this particular thing. I just with one drag and drop option, we can pull the information for all the files. So let me go there, and let me, because this is, I just did for 10 files, just that will be suffice for our demonstration purposes. And let me select 2 to 10 and drag these files and drop these files over here. Okay, that's it. This is in real time. We can get all the information. Similarly, I can pull all the XYS parameters. You see here, I can go to my join so that I have all the information regarding the XYZ parameters, also reflection and transmission coefficients for all these particular points. Okay, assuming that you have 18,000, it will do in real time. That is the beauty of the Monarch. Okay, we can handle huge amounts of data, and also if you generated any large data, also fine. It doesn't. It can easily handle. And then I do have, once I have this particular Monarch, I had my structured data transmission and reflection coefficient values for each data points. And then I can go back to my presentation. There's a short demonstration of Monarch. I got, as I told you, I got the Excel table. Then I can go to Compose for image reconstruction. I can pass the structured data to Compose, and there one can have a signal processing algorithms. They can write it in Compose, and they can use that for further processing. Probably they can use it for 3D, for they can use a fast Fourier based algorithms that are available. They can write it in Compose and process the data and form the image. Okay, and this is conclusions. As a we used the Altair softwares like Feko to generate the electromagnetic simulations, and Altair Feko can provide the transmission and reflection coefficients at the various points of the human, so that we can mimic the get the image of this particular 3D image. Then we can use Data Prep Studio Monarch for structuring the data, and then we can use Compose to process the data. That means this we are really mimicking the real world scenario of millimeter wave square and are using simulations. And in this blog, we also discussed about I presented about structuring the data, how we can extract the information using Altair Monarch and form a nice structured data so that we can further use it for further processing. Okay, thank you. I hope you enjoyed this particular blog, and thanks.